In our previous long division video, we learned how to solve division problems with multi-digit numbers, where we take a one-digit number to divide. But what if the divisor is not just one digit, but two digits? How do we handle problems like that? To do that, let's start with what you know: 4,658 divided by 2. This way, we warm up our mind to handle two-digit divisors. Okay. As always, the first step is to divide the first digit of our dividend by 2. For now, all the other digits stay frozen, so we are just looking at 4 divided by 2. Now we ask, how many 2's would it take to make 4, or almost 4? Well, 2 2's will make 4, and that's good news, so we put a 2 in the answer line. And remember, the answer digit always goes directly above the digit we are divided. Since we divided the 4, the 2 goes right above it. Now we multiply. 3 times 2 equals 4, so we write a 4 below the first 4 so we can subtract. 4 minus 4 leaves no remainder. But we are not done yet, we still have other digits still frozen. So what do? We bring a copy of the next digit down beside the 0, forming a new mini problem 6. Now we ask again, how many 2's would it take to make 6, or almost 6? Well, 3 2's will make 6 exactly, so we put a 3 in the answer line directly above the 6. And don't forget to multiply. 3 times 2 equals 6. We write a 6 below the first 6 so we can subtract. 6 minus 6 equals 0. But again, we still have 5 and 8 waiting in line. So we unfreeze the next digit, 5, and break equal to a bit down beside the 0, making it 5. So we asked, how many 2's will make 5, or almost 5? 2 2's will make 4, and that's the closest. So we put a 2 in the answer line above the 5. Now we multiply. 2 times 2 equals 4. We write a 4 under the 5, now we subtract. 5 minus 4 leaves a remainder of 1. So we unfreeze the next digit and bring it down beside the last digit, forming a new number 18. Now we ask again, how many 2's will it take to make 80? Well, 9 2's will make 18. That's what my trusty table says. So we put a 9 in the answer line above the 8. Now we multiply. 9 times 2 equals 18. We write 18 below the first 18 so we can subtract. 18 minus 18 equals 0. Now we have nothing again to show for. Let's move on. Let's take 96 divided by 18. Now, this one feels a bit different, and I know you won't be impressed because our divisor is no longer a small one-digit number. It is 18. But the idea is still the same. We still move step by step from left to right. So we look at 9 first and freeze the 6 for a moment. Now if we ask how many times 18 fits into 9, that will be none. This happens because our divisor is bigger, so we don't force it. Instead, we combine the next digit, so together they form a team. If you want, you could put a 0 above the first digit, since the 18 wouldn't divide into it any times. So we can ask a new question. How many 18s would take us 96, or almost 96? Instead of thinking 18 and 96 are difficult numbers, we temporarily think how many 20s will go into 100, since 18 is close to 20 and 96 is close to 100. That'll become easier to see. We know 20 times 5 equals 100, so that tells us what we need to know. So we place the 5 in the answer line, right above the 6. Now we multiply. 5 times 18 equals 90. So we write 90 under the 96. There we have it. Now we subtract. 96 minus 90 equals 6. But I have one thing to point out. Whenever you estimate a number after you just multiply and subtract it, make sure your remainder is lower than your divisor, like what we did here. Likewise, if your remainder is bigger than or equal to your divisor, then know that you underestimated it. Let's say we made a mistake in our estimation and choose 4 instead of 5. 4 times 18 equals 72. And when you subtract 96 minus 72, give us 24, which is bigger than our divisor. That tells us we need to raise our quotient a bit. Alright, back on track. Sometimes the numbers doesn't fit perfectly on the first try, and that is okay. So we say 96 divided by 18 equals 5, remainder 6. And I know this next one will be easy. Let's take 108 divided by 12. Because we got a hint on how to handle a divisor, in this problem, we don't even need to start with just the first digit. Instead, we combine the first 2 digits so together they form 18. Now we have 10. We still ask the same question. How many 12 will make 10? That will be none. 12 cannot go into 10, but that is okay because we have a good neighbor waiting right beside it. We combine the last digit. Now we have 108. That means there are some cases the divisor will force us to take the entirety, and that is okay. Now we ask, how many 12 will take us to 108 or almost 108? If you have your multiplication table handy, then you know 9 times 12 equals 108. That fits perfectly, which means we don't have to estimate at all. Now we multiply. 9 times 12 equals 108, and when we subtract, it leaves no remainder. As you notice, taking more digits at once results in fewer steps, which sounds friendly until you sit face to face with a bigger problem. Let's try another long division problem. 642,735 divided by 15. Now this one looks tricky and maybe even a little scary because it has apexes sitting out front. Since we have a 2-digit divisor, we always start by looking at the first 2 digits. We look at 64. Now we ask, how many 15s will go into 64 or almost 64? We estimate 15 is close to 10 and 64 is close to 60. We know 10 times 6 equals 60, but that won't help us here. But if we blindly choose 6 and multiply it by 15, that number will be too big. So here's the key. The 6 is what is causing the trouble. Why about we try a smaller digit instead? Let's see how much 4 will do. 4 times 15 equals 60. That works perfectly, so we take 4. We write 60 under 64 so we can subtract. 64 minus 60 equals 4. Now we increase the next digit and break it down. Now we have 42. Now we ask, how many 15 will go into 42? 15 times 3 equals 45, which is too big. So we try 2. 2 times 15 equals 30. That works. So we take 2. Now you subtract. 42 minus 30 equals 12. Now we bring down the next digit. Now we have 127. Now we ask, how many 15s will go into 127? We estimate 15 is close to 10 and 127 is close to 120. We know 10 times 12 equals 120, but that will be too big if we multiply 12 by 50. So the real answer will be close to 8. Now we test. 8 times 15 equals 120. That works. So we take 8. Now we subtract. 127 minus 120 equals 7. Now we bring down the next digits. How many 15s will go into 73? We estimate 15 times 5 equals 75, which is too big. So we try 4. 4 times 15 equals 60. That works. So we take 4. Now we subtract. 73 minus 60 equals 13. Now we bring down the next digit. Now we have 135. Now we ask, how many 15s will go into 135? I know this one. 9 times 15 equals 135. That works perfectly. So we take 9. Now we subtract. 135 minus 135 equals 0. And now we are done. 642,735 divided by 15 equals 42,849. And just like that, we break big numbers down, we estimate when needed. And that's how long division becomes. With 2-digit divisors, it's all about estimation. If the numbers feel tricky, you run them so each step becomes easier to handle. And once you do that, even big numbers start to look easy. So keep practicing, and I will see you in the next one.